open-ended.
Sorry, we should have turned that on earlier.
That's right, we totally forgot. Sorry about that.
Thank you.
Forgot to record, but here we go. So there are interest groups who are open-ended a little bit more in terms of their duration. They are more general and they don't necessarily have deliverables. Working groups are more short-term, they're more specific and targeted, and they do have deliverables that they produce. I believe that there are something like 60 interest groups and 45 working groups, and now there's also communities of practice. So there's various ways of doing this. So at RDA, we've had several working groups and interest groups who have touched on aspects of reproducibility, and I want to mention just a few of them here. So I already mentioned the reproducibility interest group, and I'll also, it's in that first box on the left. Also the preservation e-infrastructure interest groups. These are not active at the moment. RDA is only 10 years old, but these groups had a period of time when they were active, and then they are more dormant right now. But the reproducibility interest group at the time was co-chaired by Bernard Schutz and Victoria Staden, and its mission was to advance and enable reproducibility in research-based or producing data sets, and to provide community-based recommendations and infrastructure solutions. And they worked closely with the preservation e-infrastructure that was mostly focused on repositories. Since then, there have been other efforts. There's been the Cure Fair working group that I co-chaired along with Tom Honeyman and others that focused on curation. We had the Fair for Research Software working group that focused on applying the FAIR principles to research software. FAIR for VREs is something that is being, that is happening right now. So virtual research environments and producing FAIR products and virtual environments, and how does reproducibility fit into that? And along with some others that are maybe more domain specific and tool specific groups. So all of these different groups have touched on reproducibility in some way: preservation, certification, curation, software related issues, training, education, and so forth. So in our next part of the session, we are going to hear from some efforts that are happening outside RDA. As I mentioned, the speakers that we have are all accomplished in their own fields, and they've taken on the mantle of reproducible research, sometimes in addition to everything else that they do. And we are very grateful to all of them for agreeing to participate in today's panel. So I will just say a very brief word about just introduce each of them now. I will point to the collaborative notes to say that there's fuller bios of each of them. I just don't want to take too much time doing that. But each can also introduce themselves and tell us a little more about what they do. So we'll hear in order, and this is alphabetical order by last name, from Philippe Bonnet, Professor of Computer Science, IT, University of Copenhagen, followed by Lauren Cadwalder, Open Research Manager at PLUS. Patricia Hartridge will talk, who is a resident fellow, Open Life Science, will talk to us a little bit about the Turing Way. Christophe Perignon, Professor of Finance, HEC Paris, will talk about Cascade and other initiatives. Etienne Roche, Associate Professor of Psychology and Clinical Language Sciences at Reading University, will talk about UK Reproducibility Network and some of the other initiatives he's involved. And Alexander Saragoglu will talk, who's a postdoc in psychological methods from University of Amsterdam, will talk about open science communities and what they bring into this discussion of reproducibility. So I think that that's all I had as a matter of intro. Please take a look at the collaborative notes, add your comments and your questions and your notes, and I will turn it over to Philippe as the next speaker. Each speaker can, will just go on from in turn. You'll see the slide kind of being a milepost, a signpost for these turn taking. So with that, Philippe, please take it away.
Thank you, Limor. Everything okay? You can hear me?
Yes.
Very good. Thank you very much for the introduction and the invitation, Tom and Limor. It's a pleasure to be here. I'm here to talk about an initiative at the ACM about reproducibility. So we have a goal to become a special interest group. So there are, a lot of similarities between what we are trying to do within ACM and what we're talking about here within RDA. So the name of the interest group is called Reproducibility and Replicability. We changed name a few months ago from reproducibility and independent verification to reproducibility and replicability to match the definitions from the National Science Academy that Limor just gave. We're an emerging interest group, so we're in the phase before we become a SIG. So a few words about the ACM. If you can change the slides. So ACM is a professional organization for computing professionals. So it's researchers, students, professionals. All the activities are, most of the activities are in the context of those special interest groups. So there are, I believe, 38 of those. ACM is also in the business of publishing. So, conference proceedings, journals, magazines, books. And then there's a digital platform called the Digital Library, which is there to publish both the ACM publications and curated and so full text publications from other publishers. A few interesting things about ACM. It's also involved in education. So there's an education board that is working on the computing curricula, which is very useful in a lot of institutions. There's the computing classification system, which is useful for library science. I want to also mention this notion of artifact review and badging, which was introduced a few years ago and revised in 2020. It's basically put the emphasis on artifacts availability, artifacts reproducibility, artifact replicability, and the fact that results can be reproduced or replicated. So conferences can, in the review process, have an additional process. So instead of just accepting the paper, you have also a process to associate a badge to the paper. And the badge is basically part of the digital library. So a few words about what we're doing in the interest group. So we have two working groups. One focused on conference, the other one focused on practices. So Limor is in charge together with Vicky Rampin of the practices working group. The output of that working group has been a couple of things I want to mention. The first one is a blog called Taking the Pulse. So it was a series of meetings back in 2021, which led in publication, in education, in curation. So we brought a few people together and got some insights from that. So there's been a very interesting process, and Taking the Pulse is a very good name for that. So basically engaging the community and collecting feedback. There's also a newsletter which is now finished and that will be distributed and available on the ACM Digital Library in the coming weeks. In terms of conference, we're in the process of reviewing papers for the first ACM conference on reproducibility and replicability. It's called ACM Rep. It will take place from June 27th to 29th in Santa Cruz. There's a website, so you're welcome to look it up. I'll put that on the notes as well. So our goal with the emerging interest group is to focus on the community and fostering a community around all the issues related to reproducibility within the computing science. So to finish in terms of challenges, I want to mention a few points. The first one is that even within ACM, reproducibility is a fragmented landscape. Different communities have different practices, different objectives, no longer different definitions of reproducibility because everybody's agree on the definition, but different ways of doing things, different practices. Our goal is to make sure that we don't have a one-size-fits-all. We don't want to come up with one solution for everybody. It's not going to work. There's always going to be fragmentation, but we want to avoid silos. And as I understand it, it's also one of the main objectives for RDA, to avoid the fact that people are working on their own independently from each other. We want people to exchange and cross-pollinate and get idea and incentives from other communities. So that's the first thing. The second point, I'm the first, so I'm you know, it's easy for me to make all those points. One of the insights from the Taking the Pulse activities was that a realization that reproducibility is very labor intensive. And if we want to advance reproducibility, we have to realize that it's a labor intensive activity, and we have to promote not just the creation of reproducible artifacts, but also the use of those artifacts. We have to be able to teach people how to use and get that into their practices. So the first aspect is not just production, but use of artifacts is important. And then there's the incentives. It's an obvious point, but we need to balance the incentive between, so who's doing the labor, who's responsible between the authors, the reviewers, the curators, and the publishers and the reviewers, okay? So balancing the incentive, balancing how the labor involved in reproducibility is done is a big issue.
Okay, Philippe, you have 2 minutes left.
Yeah, it's my last point.
Okay, great.
So reproducibility, I like this. I like to view that as a way to enforce community-wide objectivity. Reproducibility is really important because it leads to better science. And what we need to do, especially in terms of education, and for everybody to reflect upon reproducibility, is to think about the scientific method as a whole, and think about how to educate for ACM, it's computing and data science students, about the scientific method in general and reproducibility in particular. So that's all I have. Thank you.
Great, thank you.
Thank you very much. So next we'll hear from Lauren, and I'll hand you this if you'd like. And then answer on the slides. Does that work? Yeah.
Hello. Oh, is that working? Sounds like it. Well, can people online hear me? Anyone give a thumbs up? Great.
Okay.
Great, thank you. So my name is Lauren Kedwalder. I'm the Open Research Manager at PLOS. So if you don't know PLOS, it's a non-profit publisher. We have an open science mission. So my role is to really think about kind of data and code-related initiatives that can kind of push open science forward. I want to talk a bit about the kind of work we've been doing around kind of code-related activities, and just to acknowledge at this point that we already have a mandatory data sharing policy that's been in place since 2014. Right? So we've got a data sharing side, reproducibility should be covered. So I've been focusing a bit on code the last few years. So just to kind of run through the kind of things that we've been doing. So in 2020, we were kind of running some surveys around code sharing attitudes, and we kind of started with code sharing because you know, it's that first step to reproducibility, right? You've got to share something in order for it to be reused and you know, see if you could reproduce work. So we're focusing on just like getting people to share stuff in the first place, and then we'll focus on kind of quality afterwards. So we ran some code sharing surveys to find out how willing people were to share stuff. This led us to implement a mandatory code sharing policy at one of our journals, PLOS Computational Biology, and that's a community that we're really keen for code sharing. You know, what we were hearing from the community is that we want to share our code. Just, you know, make a policy, and we'll do it. You know, we'll encourage those remaining people in our community who aren't so willing to share code to share it. And so we launched that a couple of years ago, and that's been working really well. And off the back of that work, we started thinking about actually, so how can we facilitate code sharing and reproducibility better? Do we want to think about some kind of notebook solution or something like a codation solution at our journals? So we ran some more research on that, we did some more surveys, and we kind of looked at actually what do readers want to, what do they want in the form of the code that they're kind of consuming as someone who's reading a published article, and you know, which has accompanying code. Actually, what do the authors want to do when they're publishing their article and sharing their code alongside it. So we did some work on that. That got published in PeerJ last year. There is a link to that article on the next slide. And then off the back of that, I ran a couple of sessions at the RDA kind of International Data Week conference last year in South Korea. And one of those sessions was trying to bring publishers together and actually talk about our experience in getting researchers to share their code and provide kind of infrastructure or services to make that easier for them. And try and find out, is that working very well? What have we learned in the last few years? And also we ran a Buzz of Feather session, again with Tom Honeyman, thinking about code sharing needs and what we might want to come together and do about kind of sharing that code that accompanies a publication. And actually, I'm going to be talking about those results in the session following this one on data policy standardization. Tom will be talking about that in the software source code group, so go to one of those two after the break. And then finally, kind of late last year, at PLOS, we developed what we call open science indicators to look at the open science behaviors of our authors, as well as kind of authors in comparator journals, to actually work out how much code are they generating and how much code are they sharing in these different communities. So we actually have a baseline that we can work off when we're thinking about, how many authors are there that could be sharing something or need to share something. So a few things, what have we learned from all of those activities? Well, first of all, from that Open Science Indicators project I just mentioned, we learned about half of the researchers in the life sciences and health research that PLOS published are producing code, right? So now we have a kind of number, a target of researchers who we can think about when we're designing or looking for solutions. In communities where code sharing is more normalized, like computational biology, it's really possible to introduce mandatory code sharing policies. People are a bit wary of mandatory policies, but it's worked. And we see really good code sharing rates there. From our surveys, we learned that authors are satisfied with their ability to share code. That's great, but they think everyone else could do a better job. So there's that kind of mismatch between people judging their own ability and other people's ability, right? We learned that both authors and readers really like GitHub because it's a community norm, right? It's familiar technology. But as people who are really into promoting best practice here at RDA, we might be like, well, GitHub's great, but you really need to use Zenodo as well, right? So there's a mismatch, I think, between what best practice says and what people actually want to do. And authors and readers, they value having that data and code in the same place, but they're not really willing to invest time in new technologies like a CodeOcean type of thing, or a kind of containerization type of technology that would really kind of make sure those two things are together. And the main reason people want to look at shared code is because they want to understand the related article, right? So it's not necessarily that they want to reproduce the research. So we learned all of these different things. I should say the kind of things we've learned from authors and readers are generally from the computational kind of communities. So what did we hear from other publishers? Well, we heard that encouraging authors to use solutions aimed at computational reproducibility can be hard, right? And there's a lot of workflow challenges to do with publishers' systems and actually integrating new technology into established kind of workflows. But some have had great success. So, for example, Nature piloted CodeOcean, then rolled it out to more journals because they deemed it a success, right? I guess we all know this, code sharing doesn't equal reproducible code, right? So there's two things. There's getting people to share stuff, there's getting people to share stuff well, and those are big challenges. We've heard that there can be a mismatch between those writing articles, those producing data, those writing the code. And if you think about code shared articles and trying to get people to share at the point of submission, you might have someone who's completely different to the writer of the code submitting the article. So there can also be a kind of mismatch of personnel when it comes to trying to get people to perform certain tasks. And that creative technology can make reproducibility tools more attractive. So GigaScience gave a really great example where they kind of rework their whole workflow cycle to make it super easy for authors to make their work computationally reproducible. So how do I imagine the future, really quickly? Well, I think some clarity on kind of the reasons why we want this to be reproducible, right? Not just clarity for us, but clarity for authors and researchers, it could be for peer review, just reproducibility in general, so other people can come and reproduce your work. Could be because we're looking to the next step, that we want people to reuse your code, knowing that it's going to work, they can take it, rerun it, that replication kind of step. And these, we could be all of these, right? But I think whichever one we put at the front will kind of determine workflow steps and different solutions and how we frame it and talk about it. As a publisher, that's quite important, that kind of workflow steps really important for us. As we had with ACN, there's that community norm versus standardized best practice. And again, as a publisher, it's, we don't want to make everyone do the same thing. We want to respect community norms, but actually having some kind of infrastructure and workflow that's just one kind of workflow is really useful for us in terms of getting it to fit in the workflow and not making it more complicated from a business or systems perspective, but it doesn't necessarily kind of respect that community norms differences. And then the kind of last ones are kind of more clear, that we want this to be part of normal research practice, so we don't have to keep going on about it all the time, and valued as a research output. So I think those two things are kind of, I think we can all agree on, but it's that kind of workflow issue and why we're doing it, I think is something that I'm still thinking about. I think that's it for me.
Great,
yeah.
Thank you.
Thank you.
Excellent. Patricia, please.
Hello, everyone. My name is Patricia Hatterich, and I'm here on behalf of the Turing Way community and to introduce that project to you. So first of all, what is the Turing Way? It's an open source guide on data science and open research. So it's a book that you can read, but it's also a global community, and it's an open source project that's built on GitHub. And we're trying to kind of change the culture of collaboration in research and make data science reproducible, ethical, collaborative, and inclusive for everyone. Where does it come from? It started as a small short-term project funded by the Alan Turing Institute, which is the UK's National Institute for Data Science and Artificial Intelligence. So they gave us a little bit of money to write a guide for reproducible research. Our tagline was that we want reproducible research to be too easy not to do it. So we brought together some resources on open research, on version control, reproducible environments, and some other topics that you can see here. As part of that, I thought I should tell you what we meant by reproducibility, but I can skip that slide because it's basically what we told you in the introduction to the session. We also built a binder hub at the Alan Turing Institute. So a binder hub is kind of cloud-based technology where you can package up a GitHub repository in the environment that you used to run your code in, and then with the click of a button, someone can look at an interactive, mostly Jupyter notebooks, and play around with your code and your data. And that's one way to make research reproducible. So we ran a bunch of workshops teaching mainly early career researchers how to use Binder Hub and understand some of the concepts behind reproducibility. And yeah, that's where we started from. As part of these conversations, it turned out that the technical aspect of reproducibility is one thing, but it's embedded in the wider research system, and you're trying to encourage early career researchers to make research reproducible. But if they get those skills at the end of the project, it's kind of too late. You want them to think about things early on. You want them to learn about collaboration so they can get other people on board. So what was one book is now 6 books. Reproducibility is still there, but we also have we also cover project design, communication, collaboration, and ethical research. And the community handbook is kind of the meta book, bringing everything together, documenting the processes of the community and how the Turing Way is run. I said that one of the big pieces that we're trying to do is change research culture. Some of the things that we are trying to do around that is like actually spend a lot of time on maintenance and community care, which is like, you know, the hard part. Everyone gets excited about new shiny things, but there's actually a lot of value in just keeping everything that you have up to date and caring for that. We have translation and localization teams who are taking the resource that is written in English and are translating it into Spanish, Portuguese, Turkish, and just creating different versions and making it even more accessible to and like kind of reducing the dominance of everything has to be in English. We're working on open governance and open infrastructure for the project itself, but also how others can learn from it. And a key part is to really be welcoming and mentoring research at every stage, researchers at every stage in how they can contributing, understanding where their contributions fit in, teaching them GitHub if they've never used it before. As I said, we started with early career researchers, but a key point is really that it's never too late for you to learn new skills and learn new concepts and engage with that. So for, to change this research culture, I think one of the biggest challenges is money, I would say, because to do all this, like you need a team of people. It's to quote Kirsty Whittaker, who is the PI for this project. She gave a talk yesterday that said that was titled "Stop Breeding Unicorns." Like, don't try to force individual people to have all these skills. And the Alan Turing Institute, where the core team for the project sits, really tries to set an example, employing community managers, project managers, research software engineers, and kind of building teams that take that on, and where everyone has their expertise, where they are like together can really shepherd the research projects along and support them in making their research more reproducible.
2 minutes for Sushi.
Yeah, getting there, because what I have left is plugs. So if you find this interesting, and any of the projects that you are working on, you think that, like, you know, they could be in the Turing Way mentioned there, and we should link out to you. Join a community event. So there are regular sessions running, and the big thing is really like twice a year, something we call the Book Dash, which is basically a week-long event where most of the new contributions to the books happen. Applications for that are still open, so you have until the 3rd of April to get your application in if you want to be part of that. And one of the other community things we're doing are fireside chats. I said, like, the humans are important, and a lot of this is often volunteer work, because I said, like, the money isn't there yet. So this is one that's close to my heart, the next fireside chat coming up, talking about burnout and how to care for your community. And with that, I'd like to thank all these people that made up the Turing Way, that I'm honored to talk on behalf of today. All the links are there if you want to get in touch. And for those in the room, I do have stickers.
Thank you so much. And can we just say how cool the illustrations are?
Yeah.
By the Turing-Way materials. Thank you very much, Patricia. So next we're going to hear from Christoph, who will be, I will move the slides for you, Christoph, so you let me know what you need.
Thank you very much for your help. Thanks for having us. I'm delighted to be with you to talk about research reproducibility in economics and management, which is my field, and about Cascade. I'm founder of Cascade, and as you can see from my first slide, Cascade is a third-party verifier for computational reproducibility and economics and management. Okay, so next slide, please. So let me provide you with some background information about economics. As you can see, in terms of reusing the code developed in academic papers, we're not the worst, but we're not good. Okay, and if you want the chain of science to be strong, you don't want research reproducibility to be the weakest link of it. Okay, so we need to help the researchers and to do something. So next slide, please. Another feature of our field, economics, is that we use a lot of data, of course, which is not very uncommon, but we use non-shareable data. They are non-shareable because they are provided by commercial providers. We sign non-disclosure agreements. We also use sensitive data like stacks, individual data about health of people, etc. So many of the data cannot be shared. So that's something to keep in mind to understand our situation. Next slide, please. So that's the reason why we decided to create Cascade. I'm very impressed by all the other initiatives presented in this session. So you guys are large scale. So Cascade is still a very small initiative. And Cascade stands for Certification Agency for Scientific Code and Data. So we certify the computational reproducibility of some published results. It's funded by some French universities and the French National Science Foundation. We have a website and people can request such certification from us. I'm going to elaborate this in a second. We had the idea to help researchers. That was the initial idea. And now most of our activity, I would say like 80% of what we do right now is more like we work with journals. So we do like B2B, which is us working with journals, and B2C, which is us working with individual researchers, which was the original idea. Right now, we run close to 300 verifications. So next slide, please. So as I told you, this slide is about if you want to know more, we have a nice video that you can get on YouTube. Next slide, please. Yeah, so the two actions or services that we provide is, as I said, the first one is for researchers. So the way it works is that if we start from the top, it's a request coming from authors, individual researchers. They want to get the certificate from us. They are going to provide all the code, data, and the article that they wrote. And then we are going to appoint a full-time reproducibility reviewer or verificator working for Cascade. He or she will run the code and the data, produce all the results, compare the results regenerated with the ones in the papers. If we have a perfect match between both, we deliver a certificate. We have a system of ratings. RRR is the best one you can get. Double D is the worst. Double D is the worst one with huge discrepancies. And if you're happy with the score you got, you can, when you submit your manuscript to a journal, you can add this certificate you got from Cascade. Okay, that's the idea. That's the service we do for researchers. Next slide, please. As I told you, we also work with journals. So that's completely different. With researchers, it's pre-submission. When we work with or for journals, it's pre-publication. So the paper has been reviewed already. The paper is right now is conditionally accepted. The last condition is someone checking the reproducibility of the results. Okay, so the request comes from the journal. The journal will provide us with the code, data, article, which is about to be accepted by the journal. And then the next step are the same as before. We have a reproducibility reviewer running everything, checking everything, and then writing a reproducibility report, sending this to the data editor. The data editor, depending on what he or she reads, will either accept the paper for good or ask for more data, more information to the authors, and then we start a new circle on my slide. Okay. I would say on average we have like two rounds, but maybe we'll talk more about that later. Next slide, please. Yeah, so this so-called execution report or reproducibility report, this document, because we are auditors, so we explain everything we do. We describe the data we got. Next slide, please. Then we describe the code, the structure of the code, any problems we faced, any errors, any bugs we had to solve, the one we have been able to solve, the one we were unable to solve. Next slide, please. And then all the replication steps, so everything we did, etc. So the list of all the problems we faced, etc. As I said. Next slide, please. And then the findings. We reproduce tables. Every time there is a discrepancy, we highlight this using some colors. Next slide, please. We have figures, bunch of figures in economics and management, as you can guess. Always the original that we see in the paper, and then below what we have been able to reproduce. Next slide, please. Fancy images, etc. Sometimes we have to post-process the data that we have been able to generate. We often combine different software, different languages, can be as high as 8 of them in some situation. But sometimes it's only mono software with Stata is by far the number one in our field. Next slide, please. And then, as I said before, we collaborate with journals. Now we collaborate with 10 of them, the very best in economics. So they use us as, they are their own internal team, but they use us as a supplier, as a third-party verificator. I tend to think that they send a request to us when it's very complex. We struggle because they keep the easy one, but that's very speculative at that point. They also ask us to access confidential data, as I said before. Next slide, please.
You have 1.5 minutes, Christophe.
Example of how we can help researchers and journals when they use non-shareable data. The good example is what we do in France with CASD. CASD is a restricted data access center, allowing more than 500 research teams, mainly in France, but also outside of France, to use administrative data, sensitive data provided by more than 500 sources, government sources. So we talk about individual health data. We talk about individual tax records. So that's the type of data that we are talking about. And of course, those are amazing data for researchers, but when they write a paper on this, they know that, okay, they spend 3 months to access the data, but then no one else will be able to access the data. So that's why if we go to the next slide, we'll see that the researchers, he or she can access this confidential data in a highly secure cloud environment with a virtual machine, access of the raw data, have all the computer code on this virtual machine, and then they will ask permission to get the result, put the result in their paper and publish. What they can do, the researcher can request a certification from us, or the journals can request a certification from us, because we have a permanent access to this high security environment. We can access a clone version of the virtual machine of the researchers within 24 hours. We can redo everything, and then we can certify, although the data was completely confidential. I will stop here. Thank you very much.
Perfect.
Okay, fantastic.
Thank you very much, Christophe. Wonderful. Etienne, please.
Hi there. I guess I'm not sharing my slides, right? So is someone on your end? Yes, perfect. Hi.
So I will move the slides for you. Yes.
Awesome. Thank you very much. So my name is Etienne Roche. I am involved in quite a few initiatives about reproducibility, but I'm here to speak about the UK Reproducibility Network and the Rescience family of journals. I will also speak about 2 new RDA efforts, a working group and an interest group that I'm just launching right now. Next slide, please. Thank you. So the UK Reproducibility Network is a grassroots movement that we started amongst researchers about 5 years ago now. It gathers 70 institutions, universities across the UK, and the aim was to consolidate efforts and interest in reproducibility. We grew just because we were there at the right time, in the right place, and there was a lot of interest in the political and policy context in the UK. We grew pretty big pretty quickly, and we're now formalized in very specific ways with local network leads who are the community managers within the institutions who organize and manage training, for example, these sort of things. And we also have institutional members. So these are universities that decided that they wanted to commit funding and resource to promote reproducibility. And so we have 25 universities who put their money together and to organize things a little bit. We have advisory boards, obviously, and we work very closely with a growing number of stakeholders, so publishers, policy, decision makers, as well as funders, so that we can organize reproducibility at very different levels. And so together we aim to promote reproducibility generally and organize initiatives. So next slide, please. The way we do that is we actually want to have a tangible impact and promote change across all these different levels. And so next slide, please. Again, actually, I think that there's going to be quite a few press. Sorry. Again?
Did I go too much?
No, go ahead. I should have removed these things. Thank you. That's great, thanks. And so we do want to have an impact across all these different levels, from the basic sort of low-level researchers and training of students to the very high-level policy and decision-making at the level of the funders. And so we realized that the best way to do that was to influence the way that we do within institutions, so that institutions themselves can be a pressure point towards the funders and expect a bit more from the funders, as well as organize the training from different researchers. Next slide, please. Thanks. And so that narrative was pretty successful. We were awarded quite a substantial grant last year to develop a national program. So the idea is to enact a theory of change, as we call it, so that we identify the pressure points in the system so that we can induce change at various levels. At the moment, so we have 3 work streams. One is about training, another one is about evaluation, and the third work stream, which I'm leading, is on sharing practices. And the idea is to organize and consolidate efforts at the level of institutions. So I speak with pro-vice chancellors and research deans to make sure that the universities themselves organize themselves in a very useful way. Next slide, please. Thank you. So the other initiatives that I was asked to speak about was the family of journals in Rescience. And so obviously, you know that the system of publishing research can be improved in many ways, and that we as researchers have actually agency in this system. And with a few friends, we decided that we wanted to organize our own peer-reviewed research output, and sort of organize and consolidate efforts for open science generally. Next slide, please. So we organized two journals, Rescience C for computational work and Rescience X for experimental work. And the idea is that these provide a venue for research output of reproduced work. So that is work that someone would have taken and just, so they would read a paper that they like and they decide that they want to reproduce it and learn from it. And so this is good for students because they actually get the experience of learning to put research together without having to reinvent the wheel or want to get a Nobel Prize out of their undergraduate research dissertation. It's good for researchers because they also get to learn new things. It arouses their curiosity. They learn how to do things. It's good for science generally because science needs to grow incrementally, and so we need to make sure that the results we're using are actually valid. It's good for it's good for taxpayers, obviously, because we are actually making sure that the research we do or that other people do is actually useful, and obviously it's good for society and it's good for the soul. Next slide, please.
Okay, you have minutes and a half left, Etienne.
That's perfect, because that is my last slide, and I just wanted to thank you for your time. And I wanted to highlight that there are two new working groups and interest groups within RDA about reproducibility in neuroimaging and in psychology. And I've congregated all these different efforts in a website called repro.school, and that's it. So thank you very much.
I'm furiously taking notes in my head of all the amazing initiatives and new things that are happening and expertise. Our last presenter today is Alexandra, and I will be advancing the slides for you, Alexandra. Take it away.
Thank you very much. I hope you can all hear me. My name is Alexandra Serafoglu, and I'm going to talk about the role of communities in open science. Basically, something that all previous speakers also talked about. Next slide, please. Yeah, I just wanted to quickly introduce myself. I'm a postdoctoral researcher at the University of Amsterdam. One of my main research interests are good research practices and the open science reform movement in the social sciences. I'm also the funder of the Open Science Community Amsterdam and member of the National Board of Open Science Communities in the Netherlands. Next slide. Yeah, I think we're all here to achieve one common goal, which is to stipulate change and to increase the computational reproducibility within the research community. And in order to change the way researchers do their work, we need a strategy of culture change. Next slide, please. This is the pyramid that we saw in the previous presentation, as well as the pyramid published by Nosek in 2019. Where it says that if you want to achieve culture change, you need to work on different levels. Next slide. So on the bottom level, we have the user interface, the experience and infrastructure to make a particular research habit easy and possible. Next slide, please. Then on the top level, we have the policy and incentives to make a particular change required and rewarding. And next slide. And what we often found is that this middle level, the communities, is often neglected. So basically, this middle level ensures that something like computational reproducibility is accepted within the research community and that it's a normative practice. Next slide. And I believe there's also a lot of valuable insights to gain from the community that can inform the other levels of this pyramid as well. We need input of the scientific community. We need to have a dialogue across disciplines because disciplines face unique challenges. Very important for us is also to engage research outside the open science bubble or outside the bubble of the reform movement. And also really important is to bridge the gap between researchers and the policymakers and to inform them about the obstacles they face in their particular field. And next slide, please. So our first goal is to increase the involvement of the research community in any strategy of cultural change. Next slide. One particular challenge that we faced in the Netherlands is that open science is understood as a three-pillar system where there's open access, fair data, and citizen science. Next slide. And we as open science communities would like to also include reproducibility and repeatability in this consensus of what open science consists of. So this is our second goal, is to establish computational reproducibility and repeatability of research findings as one of the key pillars of open science. And next slide. And next slide, please. So wanted to introduce what open science communities exactly are. They're local bottom-up initiatives at research institutes that aim to foster good research practices within the scientific community. We aim to articulate the needs and obstacles of researchers in transitioning to open science practices, and also to shape national policies surrounding open science and the local policies at the universities. Next slide. And the open science communities are now established stakeholders in the Netherlands. Next slide. So the first open science community was founded 2018 at the University of Utrecht. And since then, a lot has changed in the Netherlands. Every university now has its own open science community. And we're also organized with a national board of open science communities. We participated in redrafting the national plan of open science. And for my open science community in Amsterdam, we have about 300 members that are spread across 4 institutes. And we're also internationally represented. For instance, here in Sweden, there's also an open science community. Next slide. So this is just a world map of open science communities. Next slide. So I just wanted to quickly mention a few challenges in increasing computational reproducibility from the researchers' perspectives. So these are insights I gained just from talking to researchers during our events. So some challenges are just poor coding practices, especially in the social sciences. We learn how to code and we learn some programming languages, but most of them are self-taught. We have very little experience with version control. That is not a really common practice among the social sciences or in psychology in particular. Some have some basic knowledge of GitHub, but it doesn't really go really detailed. I think one of the main obstacles that hasn't been discussed today is that manuscripts are also really prone to just copy-paste errors. By the time the article is published and it went through multiple review rounds, you've updated a lot of figures and tables, and then your manuscript is not reproducible anymore, unless you're using specialized software like R Markdown to actually execute the analysis and write your manuscript in the same file. In psychology and also the health sciences, we're dealing with a lot of sensitive data that cannot be shared. We are not officially taught how to do a proper data documentation. And another challenge in reproducibility is for fields such as cognitive science and neuroscience, that we have really large raw data files and really long computing times to execute an analysis. So for instance, for my research, it can take up to 1 week to conduct an analysis, and it requires a specialized cluster. Next slide, please.
1 minute, Alexandra.
Yeah. So what we think the universities need to offer is field-specific support, such as providing computer clusters, large data storage, and training. And the training, especially for us in the social sciences, should emphasize open source software and also coding skills and version control, something that has been neglected. And a lot of the times we're talking about education and reforming the education for our students, but it's also required for researchers and educators. So from PhD candidates all the way up to professors. Next slide. And this is my last slide. So what open science communities here can offer is targeted help for each individual lab. Since we're a bottom-up initiative, we know the researchers and we can tackle their challenges really specifically. We can offer peer-to-peer support. We offer learning opportunities such as workshops, reading groups, and discussion rounds. And we're also representing the needs of researchers to the university support staff on the one hand that are in charge of the infrastructure, but also to the policymakers. Thank you very much.
Thank you, everyone. And we are on time to have our community discussion. If you haven't looked at the collaborative notes yet, please go ahead and do so. And I will turn it over to Andrew to lead us in the discussion. I'm also going to stop sharing, I think. Yep. So our speakers will show up on the screen here, I believe, if you have your video on. And there we go. Yeah, why is that not working? Not sure. Yes, please go ahead.
So what we've heard is, first of all, my thanks to all the speakers for staying to time. That means that we've now got time to have a really good discussion. We've heard from a range of initiatives that are underway in a variety of different contexts outside RDA. Limor provided some really good context at the start of the meeting about some of the activities that have occurred over the last 10 years of RDA. We just heard about a couple of new groups that are starting up within RDA with a focus on reproducibility, among other things. So I guess the question that we wanted to tackle at the start of this group is, is there something more that could be done, and is RDA the best place to do it? Those of you that have been coming to RDA events for a while will have noticed an increasing amount of software-related content appearing at RDA events. So even though the D in RDA is data, I think it's become clear to many of us that without the software, the data is either useless or hard to find or difficult to do something with. So we are seeing more and more software stuff appearing in an RDA context. And I guess I thought I would start with, is there a need for us to revisit how we might talk about reproducibility within RDA? Or is this a need that's being met adequately elsewhere? That was a question, just to be clear. Yeah, on the back. The roving mic. Sorry, otherwise the people at the other end can't hear. I hope that works. Here we go. Can the people at the other end hear the question? Yes? Okay, great.
Okay, cool.
Yes.
Picking up on one of the previous speakers, you mentioned the time it takes to run an analysis because of the scale of the data that we're working with these days and the barrier for replication. I think that is hugely problematic because then replication has a major cost. It's not something you do ad hoc. You have to provision resources. And so I suppose the question then around replication is, what are the resources? Are we looking at some resource limits? Or we prefer something as ready replicable, or whether somebody's going to say, well, you're going to need $10,000 at AWS to be able to replicate this.
Yeah, that's a very good point. I guess So we could easily spend the next half hour discussing the issues that have come up in the talks about challenges around reproducibility. I guess for this session, we were more interested in trying to get a sense of whether there was value in providing a place for those conversations to occur. So perhaps if people could think about whether there's value in having a reproducibility group again within RDA. So you and then Amy.
It was a follow-up, so if you want to change topic, you probably.
Is that okay? Yeah, okay. Amy?
Thank you.
I was first.
Thank you so much.
You sort of make me walk all the way around.
No, I tried.
Sure.
Thank you so much. Since RDA is a research data alliance, I feel like maybe there is a need for talking even more about research data in the context of reproducibility, or that intersection between data and code. And I do know that a lot of reproducibility initiatives are focusing on the analysis part, but of course, reproducing the results, rewriting the analysis is very much also feeding in all the data. So I don't have any concrete ideas for where we would put our sort of concrete actions or any potential deliverables if the interest group would like to have them, but it's just sort of an idea of how we could build on the research data expertise in RDA to inform reproducibility.
Okay, so a more data-focused approach to reproducibility. Yeah.
Thank you. Hi, my name is Amy Nerdberger. I'm coming out of the Massachusetts Institute of Technology. I'd like to build on what Annika just offered around this, and I think the formation of an interest group is a good direction to go because it allows bringing several elements together. As far as the D in RDA referring to data, I've often reflected that when I think of data, I think of it largely. In fact, that data has little meaning without the analysis that's associated with it. And so I think definitely there is that idea of what is the quality of data that makes it possible to use it in a reproducible analysis. There's also that interaction with the analysis tools themselves, or the scripts or code or machine learning models or what have you, that are utterly necessary within that larger space of the reason we talk about sharing data is ultimately for that purpose of research reproducibility in any case. So I think bringing back this idea of an interest group is valuable, and being able to consider it in the increasingly nuanced and complex space of what reproducibility can imply.
Okay, thank you. Pierre.
Pierre Sidaner from Observatory Paris. So in the context of astronomy, it's the data are open, so it's more easy and more sense. Something I didn't heard from presentation is the duration you want the reproducibility to work on. And this is a huge question. But I think we should focus on the 80% which are easy to make for reproducibility, like binary herbs, things like that. And then not throw away the rest, but start with something easy and then follow on. That's my point of view.
Yeah, the duration question is a real challenge. I was talking to somebody yesterday, they said we should be able to do reproducibility 25 years after the original data, and I just thought, yeah, so easy to say, so hard to do.
Yes, Federico Bianchini from the University of Oslo. So I've heard a lot of people talking about analysis, reproducibility analysis, and that's obviously what we're aiming for. But I come from a community. Originally, now I've changed job, where we were actually producing data using computational methods. So my question is whether this topic or this workload will be also the house for these type of communities that are not only analysis. There's not using computational methods only for analysis, but also for data generation that can be much more computational intensive and does use high performance computing, will come with another package of complexity, and so that's a general question for you actually, for the community.
Sure. And they were overlapping with HPC and other discussions. So my thanks to Maria Cruz for reminding me that there are people online who have that answer. My apologies, people online. I did have my back to you when you put your hand up, so I don't know who came first. Hugh, let's go with you.
So I hope you can hear me.
Both hear and see you.
Yeah. If I'm indistinct, let me know. So morning, everybody. So I think that yes, the RDA can make a useful contribution in this area. And I think actually a lot of the things I'm saying have probably already been said from the audience as it is, in terms of number one, I think most people from the chat and from the groups are sort of saying reproducibility is, we're talking about that is in more than the kind of bit for bit reproduction of results, which there are certainly some groups outside of the RDA who are just entirely focused on that, and they say that's it, end of. But clearly, we're saying no. There's more involved in the process there. I think it's interesting the points that Alexandra was making in terms of discussing like doing your checking, basically good practice that's there. The second point is that it's again also drawing from Alexandra's case, is the intimate relationship between software and data. So immediately I say what Alexandra was pointing out in terms of, well, we have code sets, but we have them working on very, very large data sets. We can't move those guys. We can't move things around. We have, and again, I'm probably being a bit of a broken record here, tools such as notebooks, which are incredibly popular. And they really are kind of sitting right on the, they're a bit of both in terms of software and data. So yes, I think we should be doing more in this space, not so much focusing on the bit for bit reproducibility, but about the process. And I think the one caveat that I would say is that there's a good relationship with RESA on this, and it should be thought about, okay, how can RDA and RESA work together on these sorts of things. So
just to be clear, when you say RESA, you mean the Research Software Alliance?
Yeah, sorry, my apologies for going into
not a personal grooming product company.
No.
Okay, thank you. I think Etienne, then Neil Chu Hong, then Tom Honeyman, and then whoever you are down in that corner, which I may mention in a minute. So Etienne first.
Yeah, cool, thanks. I have to say, I did not know RDA before last year. And I think, so in my experience, there are so many different initiatives wanting to help out and so on. And I do think that a lot of redundancy is a good thing in this respect. And I do want to be involved more with RDA. I mean, I've now been accepted with a work group and an interest group for various topics. I still have to figure out what exactly that means, but I'm very happy about that. I do think that there is a need for a dedicated an interest group maybe to start with about reproducibility, just for the sheer opportunity to feed into RDA what is happening outside of RDA. I think that would be invaluable because, as I said, there are so many different things and it's very difficult to keep an eye on everything. So if there was one element within RDA that was tasked with gathering this intel and trying to steer things and feed into the other RDAs, working group or interest group, committee of practice, I think that would be very useful. So thanks.
Okay, thank you. Neil.
Hi there, it's Neil Chuhong from the Software Sustainability Institute and the University of Edinburgh. So I'm one of these people who are involved in a lot of the software groups in RDA. And I think I'm going to kind of agree with a number of the comments that said and then go a little bit further. So I do think it would be useful to have an interest group on reproducibility as a focal point for bringing in information and disseminating it to the RDA community. However, I think once we start looking at going towards working groups, I would argue for reducing redundancy and instead making sure that we make use of the relatively limited amounts of volunteer effort we have in the community to make forward progress. I've been involved in a number of very successful working groups that have been RDA plus other communities. So the Fair for Research Software was RDA, Force 11, and the Research Software Alliance. I can see the same thing working across ACM and so on, where we come together to do these more specific working groups. The other thing I would say is that I appreciate that there are a lot of challenges around reproducibility in many different areas where scales get large. But I'm really struck by some of the things that the presenters earlier talked about, particularly I think it was Lauren, where actually there's a lot of work there that's not at large scales that we can make reproducible. And here I'm thinking of reproducible as, can someone else understand the science, the research that's behind this by looking at the code and being able to rerun it in some form. So I think there's a lot that we could do there through working groups, RDA jointly with other communities. And I'd urge us not to try and each set up our own working groups to look at this.
Tom.
Well, actually, I'm just going to give up the floor again because I feel like the three previous commenters anticipated exactly what I was going to say. So let's
what
pass
the
on.
other kids said?
Yep.
Okay, and another what the other kids said. Etienne. No, Philippe, my apologies.
Thanks. A couple of things just to complement what Etienne said. So I think there's a lot of value in having an interest group to coordinate and get within RDA what's happening outside. But from an outside organization, it would also be very important to have a very clear point of contact to find out what's happening within RDA. So I think it works both ways. So that's my first point. Two additional points. First, I think replicability is a big challenge. So we focus a lot on reproducibility, but I think replicability is a very important going forward. And there's a lot. So we don't really know how to promote and how to, what kind of incentives, how to organize work on replicability. So that could be, one. There's a lot of work which is needed towards that, and I think RDA could help a lot. The last point I want to make is about international outreach. ACM is very much Europe, so USA centric. So we try to do some outreach, but it's limited. The reproducibility networks that Etienne talked about are very much Western Europa. There's a lot of, there are initiatives to try and involve other countries and to broaden this type of initiative at the institution level. I think RDA, by its nature, could play a very important role in international, possibly developing countries type of outreach and defining, how to organize labor. There's a lot of it costs a lot, and how to, who's bearing the cost, and especially in this developing countries type of setup. To try and because it could create a divide as well. We have to be mindful of that, and RDA could play a very important role in that regard.
Okay, one last comment from the room.
Yeah, to be honest, I think it's actually a follow-up from the last point, but I think that when we think about reproducibility, everyone in the room probably understands how difficult it is, but certainly reproducibility kind of creates a demarcation problem between what constitutes as good and bad science. And certainly when we think about reproducibility, it is being pushed forward in the UK, in the US, and we need to be careful about not crediting science from other areas who aren't pushing forward with reproducibility right now just because we are. And yes, I do think the RDA would be useful in that international outreach.
Great.
So are there any other thoughts or comments, either online or in room, from any of our presenters or anyone else? Yes, let's do one more here. Please introduce yourself.
I'm Maria Cruz. I work at the Dutch Research Council in the Netherlands. Just following up on the last point, we also have to be careful. There was a definition, a common understanding of what reproducibility is, but this definition works in some fields of science, not in all fields of science, right? So we have to be careful, exactly what you said, to say, reproducible. What does reproducibility say in anthropology, where maybe you go and interview people in the field, and depending on who you are, you'll get different responses. So it's not reproducible, maybe in the sense of this definition, but Sabina Leonelli, she's a philosopher of science. She wrote a really interesting paper on this, on explaining that we have to be careful not to, that different fields have different interpretations and definitions of reproducibility, and if it's not reproducible according to this definition, it doesn't mean it's bad science. In those fields, it's about, yes, being open and transparent. And there's also fields where it's observational. I think somebody made a point there from particle physics that you're not going to build a second Large Hadron Collider because it will cost too much money, and you're not going to send another Mars rover because. So we have to be careful about this. What reproducibility is, it's not the same for each field, and it doesn't mean that the field is wrong or doing bad science.
Thank you. Yes. So I think we're hearing a lot of positive responses to the question about reproducibility at RDA, with some caveats, important caveats. We need to define the scope. We need to define what the limits of reproducibility might be, and also what the limits of what RDA can and should be involved. I heard positive reactions to having a role as kind of a centralizing location for efforts that are happening, and that communication should go back and forth, flow both ways. And so lots of good points here. Thank you. I'm sure we captured them in the notes and also in the recording. Yes, so thank you very much for that. I guess as far as next steps, we would love to have a sense of on paper or documented in some way of the interest in reviving the reproducibility interest group. And so if you could, in the notes, I think we will have a place where we can have you somehow indicate your thoughts about reviving a reproducibility interest group, as well as, importantly, looking at the charge of the existing interest group. So that's also in the collaborative notes. I wish I pulled it up and put it up on the screen for you, but it is in the notes. There is a charge that exists right now for the historical group, and I think it'll be very good to revisit that charge and see if it needs to be updated and in what way it might be updated. So if I can ask all of you to take a look and do that, that would be great. Andrew, is there something else there? I see a hand raised. Philippe, you have your hand raised. Is that from before?
No, sorry.
No problem. We just don't want to miss your important comments if you have them.
Yeah, so Tom has added another column, I'm assuming it's Tom, has added a column in the sign-up table for this group, so at the top of the collaborative notes document. So if you're interested in taking part in helping shape the description, the charter statement for the revitalized interest group, please indicate that in the that column on the right in the sign-up table, and then we have your contact details and we can make sure we contact you.
Right, thank you. So as follow-up, I think all of you who are interested will hear from us in some form through the regular channels of RDA. You will know what is happening. If you have an interest in taking an active role with this group, co-leading in some way, also please do reach out to Tom or myself. We would love to talk about that. And I think that's it for today. So thank you very much again to all of our speakers who came and gave their time for in the session today. And thank you all for being here today. Thank you.
Sorry, I should say, if anyone wants an RDA Tiger badge or lanyard, please come up here.
What's an RDA Tiger badge?
No, it's free. RDA Tiger is a support service for RDA working groups. So if you're looking to set up a working group you want, they will help.
Excellent. Oh, the tiger, I've heard about
The coveted tiger lanyard.